Hi guys, a very warm welcome to the to yet another session with the Azure developer community. We as a community thrive on you guys when you join us and encourage us to host such sessions. So we have yet another session today, which is by Devakar. Devakar is a software engineer with around 5 years of experience, and he is an open source enthusiast. He loves coding in Python, and he is passionate about cloud technologies. So he is here today with us to talk about Docker and what its impacts are in the open source community. So over to you, Divakar.
Okay, hey guys. So thanks for the great intro, Poonam. So let's just get started. Okay, so I share my screen. One second. Okay, so yeah, I hope it's visible, right? Okay. So the thing what we are going to study about today, learn about today is Docker. So I know everyone would have heard about Docker and what is Docker. So let's just dig deep. So yeah, everyone would have said about that the code works perfectly on my machine, but it is failing on others machine. So yeah, true. And there are a lot of dependencies, like a lot of variables that are put in before moving a code to production. Okay, so what happens is, for example, you'll be having dependencies, binary versions, and then platform, let's say like a Windows or a Mac or a Linux or different architecture. So there is a lot of complex things that are involved. So to solve all these things, there was a new system that was introduced called as Docker. Okay, so by default, what we do is earlier, before these virtualization or containerization came, what we usually do is we just install everything on the servers directly. So that's what we call it as bare metal servers. So your application, they just get installed directly over your OS layer. So that is this part. Okay, so each and every app runs over the OS. Okay, but there is a problem here. So let's say like I want to install Python. Okay, and I have several applications in Python, but the problem is each and every web server or the application that you deploy has its own dependencies. And managing environments for specific Python application, you require an environment, right? So for those environments, it's very hard to manage them. Okay, when you think about a larger scale deployments. Okay, so what they did is they found something called as uh, virtualization. So virtualization is a concept where what happens is over the hardware, what we do is we just install a single OS where this OS will act as a virtualization tool. So I guess everyone would have heard about these virtual box VMwares, right? So each and every OS will have its own limitations and plus, right? So based on that, we prefer virtualization. Okay. So for example, for the first application to be deployed over here, what we do is we just deploy a single host mission. Okay. So what happens is like for the each and every guest OS, we will have its own dependencies and its applications. Okay, so this is how it will be deployed initially. But the problem here is this hypervisor. This hypervisor is kind of like uh, a kernel layer between the hardware as well as my OS. Okay, and what happens is whenever you deploy a OS, the problem here is the OS itself will use its own CPU as well as RAM. So the compute is very high. The hardware requirements are very high for the guest OS. Okay, as well as in the app. So let's say like you are running a Python web server for the app one and Node web server on Node on app two. So the problem here is I have to install a single Linux OS for first application as well as a second application. Okay, and then the app itself will be requiring just 500 MB. Let's assume it's taking 500 MB, but the OS will be requiring 1 or 2 GBs of RAM, which is of total. It's not of big use, right? We will lose a lot of things. RAM, compute. Also added to this, privileges and security things are another bigger concern. So when you add a lot of applications, it's very hard to orchestrate them. Orchestrate them is in the sense like you have to slow down. Okay, so that's a problem, and you have to manage, monitor, and do everything. So that's another problem. So for this, what we did is we found something called as containerization. Here, what happens is like instead of hypervisor, we just have a single operating system. Over the operating system, we have some sort of containerization tool. So what we are going to discuss is Docker. Similar to Docker, we have Podman and a lot of other things. So what these orchestration tools do is they have their own individual containers. So this is a single container, and this is another single container. So for the first container, let's say this is my app one. Okay, again the Python app server. It will just have the basic dependencies Linux, basic Linux versions, as well as their primary dependencies I need a Python version app. So it will have a single entity, and again it is similar for all these things. So the on the bigger picture, so virtual machines use a lot of RAM, while containers use very less RAM, as well as the compute, and it's easy to manage these applications. So let's say like I wanted to make some minor changes or view some logs of this first application, okay, on the virtual machine, or do some sort of maintenance. What I have to do is I have to restart this entire guest OS, which is time consuming. And when you come to containers, all you need to do is just stop the container, grab the logs or make some changes and restart it. That's it. It's super fast. So that's the reason we prefer these containers. Okay. And then yeah, hypervisors. So there is a layer between virtual machines and the OS. Okay, that is called as hypervisor. These are like a kernel module which will talk between them. Okay, so the basic difference between VMs and guest OS is, so for virtual machine, okay, the size of the virtual machine is very high. Imagine every time whenever you run a, Windows OS or a Linux OS, you are installing all the necessary details, right? So the size of the operating system is very high, while the container has a minimal operating system or the base image. So your size is very small, and the speed, since it's very since the size and it has a lot of dependencies, the execution time is longer, right? So for Docker, it's super fast. Okay, let's say like I want a Ubuntu image. Okay, if I'm installing an Ubuntu image, let's say like after installation it takes up to like 10 GB. The same Ubuntu image with the least dependencies and the most least privileges and everything, in Docker I'll be having it within 100 MB. So you can compare the size, right? And execution time in Docker is super fast. Yeah, integration is again a problematic thing. So if you have your own full OS, okay, so let's say like I'm having hundreds of applications, and having hundreds of OS and managing them is super hard. But if you do the same with the Docker, it's easy. We have larger tools like Kubernetes or orchestrate, these kind of like Redshift containers. These kind of tools will help us to effectively manage them. It's super easy. Okay, so this is why, this is the difference between virtual machines and containers. Okay, so now let's dig into Docker. Okay, so Docker is, to be put in a simple term, Docker is an open source technology, okay, which uses containerization system. Okay, so what it does is, it runs as a virtual OS. Okay, it has its own host OS. It runs over that as a Docker engine. This combined part is a Docker application. Okay, and it is like a server client relationship thing. Okay, you can communicate with your Docker instance from your client or your server. It's super easy. And the Docker, you can run multiple containers, and using this Docker engine you can effectively manage them. So let's say like this particular container needs a separate networking system. In that case, I could just build a separate network, a VPC, and I can just directly assign it to this container. Okay, so it's that easy using Docker. Okay, so the architecture of Docker is, let's just say It is a client server architecture. So this is our client in the sense like the GUI part where you type in your commands, manage, orchestrate. This is the client part where you give in your commands to do some sort of execution. And this is our Docker host. Okay, so Docker host is where your entire Docker application or the Docker engine is installed on your OS. Okay, it has its own Docker daemon. So whenever I give commands, so let's say like I'm doing Docker pull, it is going to talk directly to the daemon. From daemon, it will check whether the image is available or not. If not, it will just fetch it from the registry. Registry is something like GitHub or Bitbucket. So a registry is where place where you store all your images and the details about them. Okay, so here we don't use GitHub. Instead, we use Docker Hub. Okay, for Docker, we have its own image registry. So it's called as Docker Hub. Okay, so this is the basic architecture, and the communication between the client and the host or the registry happens using REST APIs. That is the protocol. Okay, so let's say like I'm installing my Docker in my cloud applications. Okay, let's say in an AWS cloud. Okay, I can connect my laptop to the AWS cloud. Okay, using Docker APIs. Okay, it is that easy for interacting with it. So imagine if I've got five virtual machines running in the cloud, it's easy for me to connect with all the five virtual machines and get their stats or metrics in the runtime effectively. Okay, so core components. So yeah, here Docker plays a vital role. Like Docker is so simple. So let's say like I need a I need to deploy a Python application. Okay, it is going to serve me some sort of web request. Okay, maybe a REST API or a XML or a SOAP UI, something like that. Okay, so all I need to do is initially I need to build a container. So for building a container, I need a Docker file. So this Docker file is kind of like a instruction set where I'm designing that my image in the sense like this is let's assume this is kind of a OS. Okay, so I need that these many I mean this is how I'm going to design. This is the OS I require, and this is these many files I require, and I need to expose this port, and I need to like use a different user, or I need to like run it as a different entity or something like that. You like this Docker file is a set of entities in instructions, sorry, set of instructions to build this image. Okay, upon building this image, you will deploy them as a container. Container is a place or a vessel where you run all your applications together. Okay, so let's see them individually. So this is a Docker file. Okay, so Docker file, what happens is like Docker file has its own layers. So layers in the sense, I'll show you an example. So this is a Docker file. This is a Python web server where these things are like layers, each and every layers. Okay, they perform specific set of instructions. Okay, they come under like waterfall method, where let's say like from, and I'm specifying what sort of Python image do I require. Okay, so since it's a Python application, I'm just pulling directly the Python image. If not, I can also directly pull the Ubuntu or Arch Linux or Fedora or whatever the application, I mean OS I require, and I can do it. But the core concept of containerization is to keep your image very simple. That's why we are restricting to the base image of the Python itself. And this Alpine is a very tiny OS, very small OS with very least privileges and binaries that are required to perform the basic functionalities. Okay, that is the main concept here. Okay, so once I do it, okay, so this is the first layer. Similarly, I'm performing each and every layers. Okay, this is the way how I'm going to execute it. Okay, so we'll come back to this file later, but yeah, that's how the Docker file is written. Okay, and you've got commands to these Docker files where you can copy your file from your local to your container, set up environments. You can manage your credentials, secrets, everything using these environments, and expose. So let's say like I want to expose port 80, I have to mention it. Choosing this command is very vital because it is a very good practice to limit the port exposures. Okay, so that is the thing. And from images you used to do like what sort of image are you going to pull, and the run command is going to execute your commands user. So everyone knows who have got a hands-on experience with the Linux. You're not supposed to run your code with a root access, okay, root level access. It's highly not recommended. So in that case of scenarios, you can create your own user for the Docker container, and using that user with the very least privileges in the sense it won't have sudo access or folder directory access, secret access. You can like limit all the necessary things using this command, and you can run it with the least privileges. And then volumes. So volumes is another important point. So let's just say like you are mounting a hard disk, right? So in Linux, what you do is like whenever you are running an application, you would generate logs, right? So and getting the logs from the directory, and you will be storing it somewhere else for later analyzing, right? So here, what you can do is you can mount a volume. Volume is nothing like something like a object storage, where you can mount a particular drive or any volume of space or even a directory to the container, and the container will use this as a volume. So this is a whenever, even if you stop your Docker container, you will not lose your data. So volume is something like that. Okay, persistent storage. Okay, and working directories like cd, and labels are like you're giving proper tags to your Docker images. Okay, so we'll see them later. So yeah, um, Docker image. So what happens is like whenever you build an image, the basic thing first it starts with its kernel binaries. This bootfs as well as the kernel are the basic image of the Docker container, okay, Docker image. After that, it will choose whether you can prefer Debian or Node.js image or Python image or Ubuntu. That's up to your wish. Depending upon your use case, you can use it. I would recommend simple, like if you are using a Node application, just go for the Node application directly. And you can find all these details if you just Google it out. It's that super easy. Docker Node.js. And you will have all the official image details over here, starting with the latest versions and their OS. Like Alpine is a separate Linux from Clear Linux, okay, and Bullseye is from Debian. So you can find the best image that suits your needs, okay. And then you deploy this entire thing as a container, okay. In order to keep your image size to be small and good, always prefer to run commands together, okay. So let's say like I'm here, if you see I'm installing the dependencies, okay. So like let's say like I'm just sorry, I'm not able to edit it, but yeah, instead of using two run commands in separate, okay, it's always advisable to run them together. So run npm install, give all the dependencies all together. The more the I mean the lesser the layers, the better the performance as well as the size of the image. Okay, so always try to reduce your layers, okay, that is more important. And then you are exposing port. Always remember to explicitly specify your port, okay, that is very much important. Okay, so this is how you will build a Docker image, okay. And there is something else called as Docker Compose. So Docker Compose, so let's just say like you want to build multiple applications, okay. My web server requires a database. In that case, instead of writing another Docker file, what I could do is I could just write it as a compose file, like it has a YAML configuration file, where you will specify the database altogether here. So whenever the web server runs, it will also communicate with the Postgres directly. So it will spin up two containers. Okay, So one is for the web server and one is for the database, and they will mutually communicate with each other. Okay, so right now we'll jump into the code and I'll explain you how everything is. So our aim for this session is like we need to deploy a web server using Python. Okay, so this is a simple Flask code. So Flask is a package that we use for building minor web server, I mean smaller web servers. So what I'm doing is I'm just going to print hello world in the web browser. Okay, this is the concept, and I'm going to expose it to port 5000. Okay, this is a simple code, and this is the Docker file. So here, what I'm doing is I'm going to pull Python of version 3.8. Okay, and it's an Alpine based image. So let's just say like I want to find the details about it. Just go to Docker Hub, search for Python, and if you come over here, Python Docker official image, you will find the list of image types. Okay, that are supported. Okay, so 3.11 bullseye is from Debian, and you have got different variants. Okay, even you have got one for Windows and Linux, a lot of things. So currently I'm choosing Alpine because Alpine is the smallest image size. Okay, and then what I'm going to do is I'm going to copy the contents of these files into my slash app directory. So when the container is built, okay, what it will do is during build it will copy all the contents of all the files from this directory and move it to slash app directory, and then I'm switching the directory. Okay, this is like CD switching the directory, change directory, and then what happens is like I need to install my dependencies, right? So since it's Flask, okay, I'm just creating a requirements.txt file where I'm mentioning my Python application should have this dependency. So pip install and the requirements. Okay, so it will install the dependencies, and at the last, what I'm going to do is I'm going to execute this command. I'm going to run main.py. Okay, so let's just see how to do it now. So what I need to do is Docker build. Okay, hyphen t is for tagging the name of it. So we will for time being we'll call it as web server. Okay, and then dot in the sense it should pick up all the contents from this directory. Okay, so yeah, now you can see what it does is like it is talking to the Docker daemon. Okay, and it is pulling this Python image, okay, from uh, this Docker hub. Okay, it's going to pull the image from this Docker hub. So it has pulled the image, and this digest ID. This digest ID is something like the unique ID that has been issued whenever you are building an image. Okay, and after downloading the image, you can see the next layer is like it has copied the contents of this directory or whatever the files that are present here into the slash app directory, and then you can see that it has started installing my requirements. So my requirement was Flask of version 2.1.2. So it started installing it. After installing it, and this is the warning you get, since right now it is running as a root user. Since it's a simple demo, it's running as a root user, that's why it is throwing an warning. So we can neglect that. And then what happened is like it started executing this python main.py file. Okay, so once it got executed, now to see whether our docker container is running or not, the command is docker space ps, and if you hit enter, yes, hyphen a, if you hit enter, it will show you your web server. Sorry, we just built the application, right? This command will only build the application, like we have built the image. Now let's see the images actually. Docker images. So now the image is built here. You can see web server. It's with the latest tag. This is our image ID, and it was created a minute ago. See how small the image is. So it's only 57.4 MB. Even if you install a Python image, I mean Python application, with necessary dependencies to work on any of the architecture, like irrespective of Windows or Linux. The size is going to be very high. But here, if you see, the size of the image itself is very small, and it has the required Python web server. So in order to start this, okay, so the command to start it, run is docker run hyphen t is in detached mode. If I do not give hyphen t, I'll show you. So docker run, then hyphen p is to map the port. Remember here we mapped it to port 5000, right? You have to expose the port 5000. So you can expose it as port 5000, or else even I'll show you. So here, this is the internal port of the Docker application, and this is the external port. So when I'm trying to communicate, I'll use port 3000 to communicate with the application. Okay, and then the hyphen NAME is to give the name for that. So I'll give it as Python web server, and then the image web server. Okay, so if I hit enter, what happens is, see, it started it started executing the file, and right now, I'll show you. It will be exposed under port 3000. Sorry, my ports are getting blocked. Wait, let me run it over port 5000 itself. Okay, now if I check it again on port 5000, yeah, see, you can see hello world. See, I have made a get request, and it is printing it. See. So hooray, like we have deployed a Docker container, and I can show you. Docker es is a command to see our running containers. So this is our container. It is executing Python main.py file. This is its status, and it is exposing port 5000. And this is the container's name. Okay, and these are the other containers which I run. So I run for my personal projects, I use MongoDB, Redis, and Postgres. So I have their own container, self containers. Okay, so yeah, right now this is running, but the problem is I cannot exit out of this, right, this container. So what I can do is, so in order to exit from the container, okay, there is a command called as hyphen d. Hyphen d means detached mode. So if I hit it, see, it will run it as a background daemon. Okay, here you can find again the server has been deployed, and it's running successfully. And in order to see the logs of the server, container, you can give it as docker logs Python web server, and you can see the logs. Okay, this is the logs. And let's just say, like for some reason, your container got failed. All you need to do is docker restart and the container name, and it will restart it. See, I restarted it 2 seconds ago. So yeah, you can see it now. And next thing, so right now our container is running, right? So let's just say, like, I wanted to make some change. Okay, the ideal way is you have to make the changes to your file and rebuild the container. Okay, that is the right way. But in case I wanted to execute some commands into the container directly, in that case, what I could do is, there is a command. I could just log into the container. So docker exec execute -it and your container name, and you have to mention the shell. So our container will support sh. Okay, so it is not supporting bash. You can see bash is a shell and sh is another shell. Okay, so our container does not support bash. Okay, so that's why the size of the containers are very small. As I said, like they run with the very least dependencies. And if I go cd slash and hit ls, you can see app. So if you go to your docker file, you can remember that we copied all the contents of this directory into slash app directory. So if you go to cd app and ls, you'll find your docker file main.py and requirements.txt file. Okay, and yeah, you get everything, right? So technically this is again these folder structure looks similar to a linux. So technically this is a linux image, but very stripped down version where only python has only python has full dependencies over here. Most of the other languages or any other thing that is not required will be removed. That's why the size of this image is super small. Of the images. You can see the size of the image is 57.4. And let's just say like I'm making a minor change now. So let's say like I want to make a change to my, okay, I'm just running a command to see who am I. Okay, so the another best practice about Docker is instead of rebuilding everything, there is a concept called as caching. So what caching does is instead of pulling this image again and again and rebuilding it again and again, what it will do is so it will understand that there was a change that is made after the third layer. For the first three layers, there is no change, and on the after third layer, there is a change. So what it will do is it will cache all the three layers and it will come over here and it will execute the command and it will proceed further instead of running instead of pulling all the data again and again, which is time consuming and it's a slowdown, right? So what it will do is it will directly come to the fourth layer and execute it, provided there is no changes made over here. So right now we made changes, right? So in that case, what we'll do is we'll rebuild the image again. So docker build hyphen p is the tag name. So right now what I'll do is I'll just try server and I'm rebuilding it. So you can see it's rebuilding everything again because what happens is the tag name that you gave is different. Last time we gave the tag name as web server. This time the tag name is different. That's the reason it's not catching. So if I change to the older server, see it built it very soon. So if you notice it, see it says it is using from cache, right? So instead of rebuilding the entire image again and again, if the tag name, if the image name remains the same, and if there is no major changes, it will just use everything from the cache. Now, if I run it, um, -p and 5000. Okay, let me see the image name. Docker. Okay, so right now you can see it failed because the port 5000 is already exposed. You can see that Docker, Docker ps-a. If you see, we already built a server, built a container which is already exposing port 5000. Okay, so that's a problem. You cannot reuse the port again. Either thing, you can map the port to other ports. If not, you have to stop the server. So what we can do is Docker stop Python web server and then remove it. RM is to remove, -f is to force remove it. Okay, now what I'll do is I'll execute the above command. So now when I give docker ps-a, I can see my server is I mean my container is running fine and it is exposing port 5000. And if I also check it again, it will print hello world. Okay, and if I go to Docker logs by server, it will also show me. Remember, we ran who am I? Okay, that got removed from the logs. That's why. Okay, but yeah, it will run all the commands, all the changes that you do. Okay, and you can log these things to a specific log file. So since we are at the very basic stage, this is more than enough. Okay, so let's get back to the presentation. And yeah, the using the Docker file, we'll build a Docker image and we'll deploy the Docker container. Okay, so let's just say like I built it, right? So right now I've built my Docker images here. So this is my image. Um, right now, like if I want to send it to any of my colleagues who want to execute this in their mission, so let's say like I'm running on Linux and he is using Windows. Okay, the only thing we require both is Docker. If you have Docker installed in your machine, all I need to do is like I could just push it to the Docker hub where he can dump it from Docker hub to his local machine and he can execute it. There is no dependencies because this entire image carries the entire dependencies that are required for running a Python app. Okay, so it has its own Python. So my friend or my colleague does not require to install Python or Ruby or Node.js or anything. All he needs to do is just install Docker and he can pull this image and he can run it on his local machine. That's it. That's how super simple Docker containers are. And yeah, so let's just say here there is a Node.js server that's running. In my first server, it's exposing port 8001. And in my second server, and in second container, it's exposing port 8002. But you can see these two containers are talking with this single Redis container. So similarly, the containers can talk with each other, and depending upon the needs, you can orchestrate them. So if I have hundreds of containers talking to a single Redis, I can manage them. I can reroute the connections, and I can do a lot of things with this. Okay, that's where Kubernetes and Rancher, those kind of higher level tools comes into place. Okay, so now best practices. So the best practices is always prefer to use minimal base images. Minimal base images is instead of using an entire Ubuntu image, you can prefer or stick to Python directly. Okay, distroless in the sense don't install the full OS. Okay, that is first of all it's waste of time. You're going to like a waste of resources, and it's very hard to manage. So let's say like in case there is a security issue, let's say there is a vulnerability, the only way to fix it up is like you have to like update your containers. That is a tedious work. Instead you could stick to the base minimal images and they get their updates regularly. So that's a good thing. And then least privileged users, don't run it as a root user. Remember we saw that you're running warning, you're running as a root error. So that's a warning. So always create a new least privileged user and run it, and use trusted base images. So similar to Docker Hub, we have different other sites. Even I can build my own Python container, but instead of doing that, it is always best to download images from Docker Hub. I'll show you. So if you go to official images, they'll just say like these are the official images that are supported and verified. These images will I mean, they do a regular vulnerability scan. They'll check and scan for issues in these images, and they'll update them accordingly. You can run a MariaDB, Nginx, reverse proxy, MySQL, PostgreSQL, even Oracle, anything. You can run all these things in a containerized form. Instead of installing these dependencies, configuring them, it's super easy. Okay, and then don't leak sensitive information. So by default everyone in their coding they use good practices, right? So they use like secrets for managing them. So here again for Docker we have something called as Docker secrets. instead of feeding them as an environment variable which can be exposed easily, you can use Docker secrets. Okay, and there is something called as fixed tags. Fixed tags is something like remember. So this is a tag name, server name. This is a tag name. Whenever I try to reuse the name, it will throw error. So always try to use fixed tags. So it's easy, like it's a kind of version control. Okay, and there is a command called as copy. Remember, we used copy to copy the contents of this file. So there is another command called as, you can also use add. Okay, there is something called as add. It's not advisable to use add command. The reason is, apart from copying the contents of this directory, and can also how do I say, and can also like curl or like download data from URLs. Actually, you can also maliciously pass URLs. So let's just say like I'm giving like HTTP and some sort of like google.com. This copy command will not work. But if I use add command, I could make a request to this web server and get data, which is a problematic thing. Like hackers use it in a malicious way, and they'll just dump their source code into your container. So it is recommended to use copy instead of add, unless and until there is a greater use of it. And then label your metadata, and there is something called as multi-stage builds. So here we built only a smaller image today. Okay, this web server does not require any database, right? So this is a very small image. But let's say like you are building a web application, it requires a caching layer, a reverse proxy, and then a database. In that case, what you can do is you can do multi-stage build. In your Docker file, you can configure a smaller web server, small space for web server and everything. So remember this Docker Compose. So you can specify your database, and then you can build your web servers, and then your reverse proxies, everything. So it will be something like this. Okay, imagine GitHub to be your version control, and there is a database added to it. You can all interact with each other and talk to each other. And instead of doing multiple builds, you can write a single Docker file with the least privileges, and they can interact with each other and um, deploy the apps easily. Okay, so these are the best practices. Okay, and yeah, as told, like Docker is everywhere as of now. With this boom in cloud, everywhere there is Docker. Okay, earlier what people do is people used to directly install everything onto the bare metal servers, which was super hard. Okay, managing like I guess people who are using Oracle or Postgres, they would have installed it, and for configuring that particular thing itself, it takes a long time. So nowadays, ever since the boom of Docker images, all your web applications, all your backend applications can be containerized, and it can be deployed easily over to your cloud. Okay, that's how super it is. And all your cloud services, Linode, AWS, everything, they run either a way of like a Docker containerization technology, like either it's a proprietary or a open source. But Docker is an open source tool which everyone can use. Okay, so that's all about Docker now. And then yeah, guys, if you have any questions, please let me know. Okay, this was, how is the difference in versions taken care when we are building manifest files? Okay, difference in versions is like I'll show you. So here, this is a version file, right? Here, this is your version. This is a single container, right? So each time, let me do a build for you. So right now, if you see, the last time when I built it, it's web server. This is the latest version, right? So this is the latest version. I'm just tagging it now. So now let's say like I build the same thing, Docker build -p, -p, mapping it to same port for 5000. Oh, sorry. Tag name this time again web server. You can change the tag name, but I'll show you what happens is. So now what happens is like now it will rebuild the image. Okay. Each and every time you build a new image, you will get a new image ID. This will be your latest tag ID. So in your GitHub, you would have noticed something called as tags or release IDs. Okay. So here, if I do Docker images again, so you can see this is my web server. Okay, it has built with the latest tag ID. Okay, now you can compare it. Their tag IDs are different since I did not specify them manually. Okay, you can see their image IDs are different. Now let me run the same command with the tag latest. You can give the version numbers. So let's just say like I'm releasing version 0.1. I could just do v 0.1 and it will build it for me. So you can see here the tag is latest, but here it is not because I did not tag it. If I do not use anything, it will always pick up the latest image. Okay, so yeah, that answered your question. Any other questions?
Thanks, Divakar. Thanks for that session. It was quite informative. I got to learn a lot. I didn't know
Okay,
about caching, so it added, and
sure.
I hope it added value to our viewers as well today.
Yeah,
And I would like to thank everyone who took out time today on a weekend to come and join us for this session, and especially Divakar for taking out the time and sharing your knowledge with us. I would also like to share with our viewers about our community, which is Azure Developer Community. So we host similar talks every weekend or even on weekdays. So we are a community of tech enthusiasts who like to speak about topics ranging from open source to any new tools or any cloud technologies. So whatever it is you're interested in, you can join us and learn from us. I have shared the website. You can go there, check out our past talks and also our future talks that might be happening, and you can register and join us for our future sessions. Thank you, guys. Thank you for joining. Thanks, Devakar.
yeah. Thank you.
Have a happy weekend. Bye.